Hello, you're welcome back. All right, so we are going to be looking at projectile in this video. Okay, so what's a projectile? Now, projectile is the motion of an object under gravity that follows a parabolic path from the point of projection to the point where it hits the ground. Now, projectile is actually different from other motion under gravity that we've already treated, okay? Where we actually treated a vertical projection or a free fall, okay? An object actually falling freely under gravity. Okay, but this time around we're looking at an object moving in a parabolic path. Now, one thing about the motion of a projectile is the fact that if you want a projectile need to be thrown, okay, the motion must be in an angular path. For example of a projectile, we are looking at javelin, okay. This is a simple example. When you throw a javelin, you throw it in an angular path so that at the end of the day it will go, okay, it will move in a parabolic path, then return back to the ground level. All right, so as I already said, what makes projectile different from other motion under gravity is that the initial velocity is neither vertical nor horizontal, but the initial velocity is actually inclined at an angle. Okay, angle. So this theta is what we call the angle of projection. That means before you can even throw a projectile, you must incline that object, okay, at an angle of projection. All right, so now there's something you should actually take note. Since the initial velocity of a projectile is inclined at an angle, in physics, anytime an object is inclined at an angle, that object, okay, possesses two components, right? This object u, which is inclined at an angle, can be referenced in the vertical direction. Okay, so when I reference it in the vertical direction, it will have that is called the vertical component of u. When I reference it, when I look at it in the horizontal direction, it's called the horizontal component of u. So anytime a vector quantity, of course, u is a vector quantity, is velocity. All right. Anytime a vector quantity is inclined at an angle, you can actually evaluate that vector quantity into two components, one in the horizontal component and the other in the vertical component. All right, so we're going to look at this the component of my velocity components of the initial velocity of u. Okay, so I'm going to start with let's start with the vertical component. All right, so how will I be able to get the vertical component of u? Now I'm going to redraw my diagram, the diagram of the projectile. Remember, this is the vertical axis, this is the horizontal axis, okay. Then of course my u is in between, which of course is inclined at an angle of theta. So now I'll call the vertical line, which of course is my vertical axis, as the vertical component of u, the horizontal to be the horizontal component of u. All right, you discover that by doing, I've actually formed a right angle triangle in which the vertical component is the opposite while the horizontal component is the adjacent. Okay, u itself is the hypotenuse. So now if I'm looking for the vertical component of u, of course you know very well that I'm looking at the side u, or the opposite, and the side u is the hypotenuse, and that in trigonometry that ratio is called sine theta. Sine theta is always given as opposite all over hypotenuse. Opposite is the vertical component I'm looking for, uy. Okay, the hypotenuse is the u. That's the velocity I want to find the vertical component. So what do I do? Across multiply uy multiplied by 1, as uy. Okay, then of course u multiplied by sine theta, that gives me u sine theta. So invariably now, anytime I want to express my u, I want to express u in the vertical direction, all I just need to do is to multiply u by sine theta. That will give me the vertical component of u. right? So please take note of that. What of horizontal component of u? Okay, so now if I want to evaluate the horizontal component of u, that is my ux, right? Horizontal is my ux, and that's the adjacent of this right angle triangle. While the hypotenuse is actually the is u, all right? The u is the hypotenuse. So that ratio in trigonometry is called cos theta. So cos theta is always given as adjacent, which of course is ux, my horizontal component, then divided by u. So if I cross multiply as usual, I'll now have that ux is going to equal to u cos theta. So this is the vertical component, and what we have below is the horizontal component. Okay, so having the vertical component and the horizontal component, all right, so what do we do with them? All right, now in projectile, how do we solve question that should be our concern? What equation do we need in projectile? Okay, the same way we have equation of linear motion, and we also have the equation of motion under gravity, we should also have equation of a projectile. Okay, now I'm going to derive the formula for the equation of a projectile, and that equation of a projectile is an equation that will help us to evaluate the following parameters. All right, number one. Okay, so let's look at the equation of a projectile, or the formula of a projectile. Okay, it's the same thing. So the very first thing we're going to look at is the equation that enable us evaluate the time of flight of a projectile. The time of flight of a projectile. The second equation is equation that will enable us evaluate the maximum height a projectile can attain. Maximum height. The third equation now is the equation that will help us evaluate the range of a projectile. So this is capital letter T, this is capital letter H, and this is capital letter R. All right, so let's start with the very first one, which is the very first as time of flight of a projectile. Time of flight. So the question is, how do we define the time of flight of a projectile? Now, time of flight is the time it will take the projectile to complete its motion. So invariably, if I want to analyze the time of flight of a projectile, I will divide the motion of a projectile into two parts, okay? Two halves. The very first half is the time it will take the projectile to reach the maximum height. Of course, this is the maximum height, right? So time it takes that projectile to reach the maximum height, and the time it takes the projectile from the maximum height to reach the ground level. Okay, so you discover that let's call this small letter t1 and the other one small letter t2. All right, so you discover that two of them are equal. They are two halves. So the very first thing I need to do is to find the time to reach the maximum height. By time, that means the time of flight now is simply the time it takes to reach the maximum height plus the time it takes the projectile to move from the maximum height to the ground level. All right, so how do we evaluate the time it takes the projectile to reach the maximum height? It's very easy. Okay, you know what you're going to do. Very first thing, you need to write the parameters, because we are still going to apply the equation of motion under gravity here. Okay, so know very well that the final velocity at maximum height is 0. I know very well that my gravity, okay, definitely is gonna be negative. I'm going against gravity. All right, and don't forget that my u is gonna be the velocity of a projectile have two components. Okay, I only need one component. Okay, in any scenario. So in this scenario, the component I need is the vertical component. Since I'm looking at the time it takes the projectile to get to the maximum height, that is vertical, right? So I need the vertical component. Don't forget the vertical component, that is u sine theta. That's gonna be my u. Okay, so now comma, what I'm looking for now is a small letter t. Okay, question mark. All right, so okay, of course, let me call it t1. So which equation of motion? That is the very first equation of motion, which is v is equal to u, of course, minus gt gt1. So v is 0, u is u sine theta, then minus gt1. If I should rearrange this equation, minus gt1 goes to the other side, becomes plus gt1, okay, is equal to u sine theta. So that way now the time to reach the maximum height is u sine theta divided by g. So don't forget the time of flight is going to be equal to t1 plus t2. t1 is also equal to t2. t1 is u sine theta divided by g. t2 is still the same, u sine theta divided by g. So if you add that together, u sine theta plus u sine theta, that will give me 2 times u sine theta, 2u sine theta. So the time of flight of a projectile is given as 2u sine theta all over g. So please take note of the formula. 2u sine theta all over g. All right, so the next parameter or equation is that of maximum height. Okay, now the question is, what's the maximum height of a projectile? The maximum height is actually the vertical distance measured from the ground level to the point where the projectile, okay, the motion of the projectile reaches the maximum height. Okay, so the horizontal distance from this point to this point is the maximum height of the projectile. Okay, the point where the projectile of the motion of the projectile stop momentarily before it starts returning back to the ground level. Okay, so how do I get this maximum height? First of all, you should know that at maximum height, okay, v is equal to 0. We know that already. You also know that g will consider g to be negative. We're also going to what again do we need? Okay, then our u is still gonna be what? U sine theta, vertical component. Then of course for the maximum height, h, question mark. So which equation? 1, 2, 3, 4. The third equation of motion under gravity, that's v squared is equal to u squared then minus 2gh. V squared is 0, that's 0 square. U squared is u sine theta. U is u sine theta, right? But I have to square it. U sine theta all square then minus 2gh. Okay, so take minus 2gh to the other side equals plus 2gh. And of course, you know very well that if I square u here, I'm going to have u square. If I square sine theta, I'm going to have sine square theta. That way now I can get my h. So my maximum height now is going to be equal to u square sine square theta, then divided by 2g. All right. So this is the maximum height by the projectile. Alright, so that's the formula for the maximum height of the projectile. Now go to the range of the projectile. So how can we define the range of the projectile? Now the range, okay, is simply the horizontal distance covered by the projectile, okay, from the point of projection to the point it hits the ground. So this is the range of the projectile. Remember we talked about range, okay, of any motion under gravity. It's always from the point of projection to the point, okay, horizontally. You measure horizontally to the point it reaches the ground. How can we evaluate that? Now I've given you this formula, okay, and of course I don't want to prove why it is so. Range is going to be equal to the initial velocity multiplied by time. So of course I told you that already. So in a case like this, the u I'm going to consider, I'm looking at horizontal distance. That's going to be u cos theta. Why the time, okay, I'm going to consider is at this point where we are measuring the range, the motion has completed. So the time is going to be the time of flight, which of course is 2u sine theta. 2u sine theta all over g. Okay, then I'm looking for the range now. The range question. So combining this, okay, and expressing that in this equation. So range now is going to be equal to u, which of course is u cos theta, then times t, which is 2u sine theta, 2u sine theta all over g. So r is going to be equal to u times u, going to give me u square, right? 2 sine theta cos theta. Two sine theta cos theta, then divided by g. Now in trigonometry, this expression 2 sine theta cos theta, okay, is a compound angle. In fact, it's a double angle. All right, so it is equal to sine 2 theta. So please take note of that. 2 sine theta cos theta is equal to sine 2 theta, double angle of sine, okay, sine 2 theta. So putting that into this expression, so range is going to be equal to u square. 2 sine theta cos theta is sine 2 theta. Then of course divided by g. Okay, so I just proved the three equation, okay, of projectile. Just in case you couldn't get them, I have to write those three equations down. Okay, the very first equation was the time of flight, which is equal to 2u sine theta all over g. The very second is the maximum height attained, which is equal to u square sine square theta all over 2g, while the last but not the least is the range, which is u square sine 2 theta then divided by g. So we're going to apply these three equations, okay, in the next video. All right, see you in the next video. Thank you very much.